First, you learn the definition of the derivative of a function as a limit. But then you learn that limit actually represents the slope of the tangent line to that function at x equals a. We're going to use that knowledge to draw graphs of derivatives without ever touching the limit or any kind of algebra whatsoever. So here's a piecewise linear curve. And what we are going to do on the same set of axes is we are going to draw the derivative function to this curve. And the reason I start with a piecewise linear curve is because we can actually straight up measure the slopes of these line segments and get a very exact picture of the derivative. To get started, note that over here the slope is equal to 2, and I'm going way back to algebra and using rise over run. It's over 1 up 2, over 1 up 2. So this whole line segment has slope 2, this one has slope 0, this one has slope negative 8 over 3. Notice that it goes over 3 and down 8. And this line over here has slope 1 over 2. That's the slope of the line, therefore that's exactly what the derivative needs to be equal to. Okay, so if the slope is 2, f prime has to be equal to 2 on that entire interval. If the slope is 0, f prime is equal to 0. If the slope is negative 8 over 3, then f prime is equal to negative 8 over 3 over that entire interval. Notice how we're switching where these little corners are in the curve. That's exactly where f prime changes. And finally, f prime is equal to 1/2 over here, where the slope is equal to 1 over 2. And so we're nearly done. There's only one thing left, which is what to do about the 3 different corners on this curve. And remember that at those places, f is not differentiable, right? There's no single slope in the tangent line, and that limit does not exist. And so f prime does not exist. And so mathematically what we do is we mark open circles on all of these line segments to denote that actually at negative 5, negative 3, and at 0, that f prime doesn't exist at all. So it's true, this derivative curve is discontinuous. So here are some notes. If f, the blue curve, is increasing, that means that f prime will be positive. You can see that in 2 spots here, where the red curve must be above the horizontal axis because the blue curve is increasing. If f is decreasing, as it is here, then f prime will be negative. And if f is constant, then f prime is constant also, but it must be exactly 0. But notice this here, steeper parts of f, see how this line is steeper than that line? Well, then the derivative has to be higher here than it is over here. So although sometimes we won't be able to make exact judgments about what the derivative will be at various places, we do have this comparative judgment that we can make. So one final note, really important. So there's a difference between how mathematicians and engineers draw discontinuous curves. And it's really important that what we just described was that this curve is discontinuous at negative 5 and negative 3 and 0, and mathematicians use open circles to denote that. An engineer generally simply connects the 2 horizontal line segments with vertical line segments, but it is still understood that this graph is discontinuous.